Hello everyone, welcome to my fourth video lecture on semiconductor physics. Semiconductor physics. So, materials are classified into three categories according to their ability to transfer the electricity. That is, according to ability to transfer their electricity. That is, number one, a conductor, insulator, and semiconductor. So in conductor, that is, they easily conduct the current. Means here there are large number of free electrons are available. Here large number of free electrons are available. Number of free electrons. Free electrons are available. So these materials conduct the current. But in insulator, they won't conduct the current. They won't conduct the current. Why? Because they don't have the free electrons. They don't have the free electrons to conduct the current. Free electrons. But in semiconductor, as the name indicates, semiconductor means here these materials will have the medium ability. That is, these materials will have the medium ability to conduct the current. Example, silicon or germanium. So now in this chapter we are going to focus on these semiconductors. That is, we define semiconductors as, in short I am going to write the semiconductor like this. So we define the semiconductors as the materials whose electrical properties lies between the conductor and the insulator. So in terms of energy band, that is EG, that energy band, or else that is energy band, we define the semiconductor as the materials at room temperature. The semiconductor at the room temperature have the partially filled conduction band. Conduction band is partially filled here. Partially filled conduction band and partially filled valence band. These two are at room temperature. So semiconductor materials, based on the energy band diagram, they have the partially filled conduction band and the partially filled valence band. And energy gap they have, that is EG is the energy gap. That is the gap between the conduction band and the valence band we call as the energy gap or forbidden band. So this forbidden band or the energy gap is very narrow in case of semiconductor. That is, EG is very narrow. So let me tell you with the diagram. Suppose this is energy of the electron, energy of electron. Yeah. So if you take the first insulator, as you know that there are three kinds of materials. So in the insulator what happens? The conduction band, the uppermost band is the conduction band. In short I am going to write it as a CB. And the lowermost is valence band. That is VB. So the gap between the conduction band and the valence band is more, that is large. That is, the gap between the conduction band and the valence band is Eg, that is energy gap. It is large in case of insulators. If we take the conductor and the semiconductor, so I will go from insulator, semiconductor and the conductor. Again the same type of the graph, that is showing energy of the electron. Here this is the semiconductor, in short I am going to write it is semiconductor. So the gap between the conduction band and the valence band, it is valence band and the conduction band, is moderate. That is, that we call as the energy gap. It is moderate. So you can find out here the gap between the conduction band and inner valence band in case of insulator is more, and the gap between the conduction band and valence band in case of semiconductor is moderate. And what may happen in case of conductor? The same diagram, that is conduction band and the valence band, conduction band and the valence band. So there is almost no gap between the conduction band and the valence band, that is Eg is 0 here in case of conductor. So this is the energy band diagram of the insulator, semiconductor and the conductor. Now broadly there are two types of semiconductors. Two types of semiconductors. That is, two types of semiconductor. That is, one is intrinsic semiconductor. Intrinsic semiconductor and extrinsic semiconductor. So intrinsic semiconductors, they are the semiconductors in the purest form. The semiconductors in the purest forms are called the intrinsic semiconductor. So that is, we can also call intrinsic semiconductors as a undoped semiconductor. Undoped semiconductor. Undoped semiconductor. Or else the semiconductor in the purest form. In the purest form is the intrinsic semiconductor. Here in case of intrinsic semiconductor, the number of conduction electrons is equal to number of holes. But in extrinsic semiconductor, so this is extrinsic semiconductor, also we can call doped semiconductor. Doped semiconductor. So here by adding the dopant, we can change the conductivity of a semiconductor significantly. So there are two types of the dopants, doping agents are available. Maybe dopants may be doping agent or dopants. Dopants may be pentavalent or the trivalent. Pentavalent or the trivalent. These are the impurities added semiconductor. There are two types of charge carriers, holes and the electrons. Always the flow of holes occurs in a direction opposite to the flow of the electrons. Here we have the two important parameters to understand. The number one is drift velocity and the mobility. Drift velocity. Drift means here, due to the effect of the electric field, the particles, either they may be electrons or the holes, pulled by an effect called drift. That is, it is defined as average velocity obtained by a particle of a material to an electric field. That is always proportional to the current. So now the drift velocity is what? It is an drift. This is due to what? Electric field. The drift is given to the particles. The particles may be electrons or the holes here. So due to this effect of this electric field, the particles, either it may be electrons or the holes, they pulled by the effect of this electric field, so that we call as a drift. That we call as a drift here. So now how we define the drift velocities? It is an average velocity. That is, drift velocity is what? It is an average velocity attained by particles. And again, particles we mean here is electrons or the holes. So drift velocity we define as average velocity attained by the particles of a material to an electric field. So it is average velocity is directly proportional to the current. And one more parameter is mobility. So the word mobility. So what do you mean by this mobility? Mobility is what? It is a measure of how quickly an electron can move through a semiconductor in presence of an electric field. Suppose an electric field is applied to a semiconductor. So here mobility is going to measure how quickly an electron can move through a semiconductor. So that is, it is a measure of what? Measure of how quickly an electron can move through a semiconductor material. So it should happen in presence of the electric field, right? In presence of electric field. So mobility is what? Measure of how quickly an electron can move through a semiconductor in presence of the electric field. So how we give the notation to that? That is, M is equals to mobility of that is electron to electric field. So now you understood drift velocity and the mobility. So what has been covered in this chapter here is, you could learn the materials are classified into three types, that is conductors, insulators and the semiconductors. Depends on the ability to transfer the electricity. So conductors, as they have the large number of free electrons, they conduct very easily. But in insulator, there is absence of free electrons, so they don't conduct the electricity. And in the last, the semiconductor is what? As the name indicates, again semi-conducting. So the ability of this material will be medium. So these we call as a medium ability to conduct the current. So examples are silicon or the germanium. Again, in terms of the energy band, we can we can define the semiconductors, conductors and the insulators. So energy gap between the insulator is very large, that is the gap between the conduction band and the valence band is more in case of insulators, and in case of conductor there is no gap between them, that is conduction band and the valence band both are overlapping. But in case of semiconductors, what happens? They lie between the conductors and the semiconductors. So here what happens? The energy gap is moderate. So the electrical property of the semiconductor lies between the conductors and the insulators. Again, there are two types of the semiconductors, because here in the semiconductor physics we are going to learn, means we are going to concentrate more on the semiconductors. So semiconductors, there are two types. One is intrinsic semiconductor and the another one is extrinsic semiconductor. Intrinsic semiconductor also we can call it as a undoped semiconductor, or also we can call it as the semiconductor in the purest form. And in the extrinsic semiconductor we call it as a doped semiconductor. Here the dopants may be pentavalent or the trivalent. And again there are two types of charge carriers, holes and the electrons. The flow of holes always occur in opposite direction to the flow of the electrons. So again, lastly, the two important parameters you need to understand in the semiconductor, that is the drift velocity and the mobility. Drift velocity, how we define as, it is an average velocity attained by the particles of a material to an electric field, and it is proportional to the current. And the mobility as, it is a measure of how quickly an electron can move through a semiconductor in presence of the electric field. That is, M is equals to V by E.